Writing evals is going to be a core skill for product managers. Kevin Weil, Chief Product Officer of OpenAI, recently said this in a video. And having spent the last 2 years building enterprise AI agents, I would 100% agree with Kevin. But here's the rub. There's tons of content on agent architectures and even LLM evals, but little on building evals for agents of real-world complexity. That gap led me to enroll in the AI Evals for Engineers and PMs course. And 2 weeks in, it's already changed my approach to building agents. Today, I want to share what I've learned and how I've applied it to my multi-agent health system. Let's get started. In my last video, the Three Amigos pattern got me a working multi-agent health system with 8 specialist agents using Anthropic's orchestration pattern. But getting something to work once versus deploying it confidently, totally different challenges. How do you systematically evaluate agent coordination at this scale? My biggest takeaway so far in the course has been this 3-phase cycle that makes evaluation manageable. First, analyze. Run diverse health queries, watch what fails, and organize the patterns into categories you can fix. Then, measure. Turn that doesn't look right into numbers you can track. Score each failure type separately and know exactly where things break down. Finally, improve. And this was an aha moment for me. The framework diagnoses why agents failed, suggests specific fixes, and Claude Code can apply them automatically. Simple, systematic, and it actually works. Let me show you. Let's run a health query to demonstrate these eval steps in a concrete way. I'm asking about diabetes A1C changes, medication adjustments, and weight correlations. 3 medical domains coordinating, a perfect test case for agent evaluation. Here's Dr. Vitality, our CMO agent, building the specialist team and distributing tasks. You can see each specialist working. Dr. Labs on trends, Dr. Pharma on medications, Dr. Nutrition on weight data. The response looks detailed, but something's off. It says that there's no relationship between weight changes and glycemic control, yet the data shows a 30-pound weight gain. This is where it gets powerful. The moment you notice an issue, you can turn it into a systematic test case. Click Create Test Case, annotate what should have happened, and you've got a reusable test for similar issues. Meet the Eval Development Studio. 3 panels that turn evaluation complexity into something manageable. On the left pane, meet our Eval Development Assistant, aka EDA, an AI-powered agent you can collaborate with to understand the complete trace of your query execution and build out the test cases. The EDA agent can collaborate because it has access to everything in that center panel, a complete trace of the executed health query showing the number of agents involved, every LLM call with inputs and responses, each tool invocation. With all this visibility, the right panel captures our test case with the actual execution values. We'll work with our EDA agent to update these to the expected values. Now, let's use that middle observability panel to drill into this health query and see what we can find. Here's the timeline view. It shows all agents across time with their execution stages. Let's select the query analysis stage to understand how it assesses complexity. Perfect. This shows every step the CMO took during query analysis. Look at this. We can even expand the Snowflake tool call to see the actual data it retrieved. Now, let's look at the LLM response to see its reasoning about complexity. Interesting. The CMO identified this as a standard complexity query type because it focused on analyzing A1C trends. But actually, this should be a complex query type, since we're correlating data across 3 medical domains. That misqualification had consequences, it seems. It only created a 3-specialist team. This would explain why it failed to correlate with weight. Without the right specialists, it couldn't see the full picture. Now, I'll work with our EDA agent to update our test case expectations based on what we discovered in that trace analysis. I have provided 4 specific corrections: complexity classification, missing specialists, keyword gaps, and cost expectations. Check this out. After I submit my message, the test case updates automatically. The EDA agent translates my observations into structured test expectations. It's like pair programming for evaluation. I bring the medical domain knowledge. The EDA agent handles the test mechanics. This collaborative approach makes building comprehensive test cases actually manageable. Now, let's run the evaluation. First, it saves our test case as JSON in my workspace, and then it kicks off the evaluation against our corrected expectations. Here's the beauty of this approach. It replays our original trace and scores it against the updated criteria. No waiting for agents to run again. Watch the 3 phases unfold. Loading execution trace from the analysis phase, LLM as judge evaluating the specialist rationale in the measure step, and the LLM as a diagnostic generating 5 improvement recommendations from the improve phase. And we're done. Here's our evaluation report. This breaks down exactly how our agent performed across every dimension we're measuring. The test failed with a 63% overall score, and you can see it identifies 3 specific dimensions that failed: complexity classification, specialty selection, and cost efficiency. Let's dive into each failure. The complexity classification shows a score of 0, a complete miss. The root cause? It seems like this prompt lacks clear guidance on multi-domain correlation analysis. The fix? Modify the rule definitions to distinguish when queries involving multiple correlations should be classified as complex versus standard. Makes sense. Next, specialty selection scored 0.44. Notice this breaks into 2 components: a specialist precision using deterministic evaluation and a specialist rationale using LLM judge. That 0.20 rationale score reveals flaws in the reasoning when building the specialist team. The recommendation? Add explicit rules that diabetes queries mentioning A1C automatically include both endocrinology and preventative medicine specialists. Again, makes perfect sense. The third issue, cost efficiency, failed despite staying under that $1.20 threshold. The token efficiency scored 0.5. We used 66K tokens versus the expected 10 to 20K due to the verbose responses and overly detailed task descriptions. Okay, we need to fix that as well. Notice that each failure showed the same pattern: precise scoring, root cause analysis, and actionable fixes. No more guessing what went wrong. This is systematic debugging. Now, let's close the loop by applying these improvements. Here's our VS Code workspace with 3 panels. The center panel shows our eval README with the end-to-end evaluation development flow. You can see we just covered steps 1 through 6. Now, we're moving to the final steps where Claude Code can apply the fixes. Now, let's look at the left panel. VS Code automatically detected 3 new unversioned files: the test case we saved earlier, the eval report HTML, and the raw results from our previous eval run. Everything integrated seamlessly from our Eval Studio session. Let me show you what we've created. Here's our test case as structured JSON with the query, expected complexity, specialist, and all of our evaluation criteria. And here's the raw evaluation results, showing our 63% weighted score and the detailed breakdown of each of the dimensions that failed. Now, I'll start Claude Code in that right panel. Claude Code analyzes the entire code base, detects our failed evaluation, and asks if I want to apply the recommended fix. Wow, another aha moment. Watch this systematic implementation plan. It maps each recommendation to a specific prompt file and shows exactly what changes it will make. Claude Code then applies those changes, updating complexity classification rules, adding specialist selection logic, and optimizing token efficiency. After completion, it provides the command to rerun our tests. Okay, let's run the test case via the CLI command. After the test completes, we see the Eval framework has created a new Eval report. Let's open it up. Check that out. Notice our evaluation test now passes with a score of 94%, and all the dimensions are green. A complete turnaround from our original 63% failure. This is what makes the cycle powerful. Evaluate, diagnose, fix, and verify. Remember what I said in the beginning? There's tons of content on agent architectures, but surprisingly little on evaluating agents of real-world complexity. Well, hopefully this gives you some concrete examples and a practical approach that's been missing. I've documented the complete approach in my blog, the Eval Development Studio, the evaluation framework, and the integration with Claude Code. Plus, I've added the full integration module to the Multi-Agent Health Insights GitHub repo so you can see exactly how this works in practice. This combination, courses like AI Evals for engineers and PM, teaching this methodology, concrete examples like what you just saw, and tools that make it practical. That's what will help PMs and engineers finally build production-grade enterprise agents instead of just mere prototypes. Kevin Weil said evaluation would become a core skill for PM and engineers. What I just demonstrated shows we're at the right inflection point where it's shifting from theory to everyday practice. Good luck.